Okay, I'm going to talk to you a bit about how to figure out some things about your mystery class in terms of, is your mystery class north of the equator or south of the equator, meaning northern hemisphere or southern hemisphere, and then how far north of the equator or south of the equator is it? Using that, we can start to get an idea as to where our mystery classes are and start to look at some specific places it could be. So first off, I have mystery class number 11 here. With mystery class number 11 is one that is made up. I just found a place in the earth and made it work that way. But our same ideas are still there. These are still the sunrise and sunset and photo periods of this place, so we can still use it. If we look at the photo period of mystery class number 11, it starts at 8:44 for the photo period, less than 9 hours of daylight there in January. And it increases every single week. So it's getting longer and longer and longer and longer. So this means that this place is transitioning from short photo period, which we see in the wintertime, to a longer photo period, which we see in the summertime. It's up to over 13 hours of daylight on April 1st. So going from winter to summertime means that that is similar to where we are, which is in the northern hemisphere. So if we see the photo period increasing as the weeks go by, we know it's in the northern hemisphere. Southern hemisphere would be opposite. We would have a larger number up here and a smaller number as we go down. So that's how we can tell if it's in a northern or southern hemisphere overall. But then we're going to want to compare it to DC Everest Middle School. I'm going to scroll down to the middle school, which is this information here. And we see at the middle school we start at about 9.5 hours of daylight, and we are ending up at 12.75 hours, so still under 13 hours of daylight. So this changes like that, and we're at about 45 degrees latitude. We're about halfway between the equator and the North Pole. If a place is changing time faster than us, meaning they start at a smaller number and get to a bigger number, that means that they're further north of us than we are, closer to the North Pole than to the equator. If it starts with a number that's larger here and doesn't go up as fast, so it doesn't get up to as big of a number, then we know it's in a place between us and the equator. So if the rate is changing at a speed faster than we are, it's closer to either the North Pole if it's in the northern hemisphere or the South Pole if it's in the southern hemisphere. So in the southern hemisphere, we'd see a relatively large number up here that's getting smaller faster than ours is getting bigger. If it's closer to the equator, we would see a number like we have here, but it's getting bigger at a smaller rate if it's in the northern hemisphere, so it's still getting bigger, but not as fast. See, we're changing by almost 20 minutes every single time here. So if it's south of where we are, closer to the equator, it will be less time each time. And if it's closer in the southern hemisphere, closer to the equator, it would be getting smaller, but it'd be at a rate smaller than ours.